Hey everybody, we're here today talking about how to construct polynomials using basic operations. In this case, we're going to talk about addition, subtraction, and multiplication. So adding polynomials. Just like we can add numbers, we can add two polynomials together, right? So we're going to have 7x squared plus x squared gives us 8x squared. Negative 4x plus 2x gives me negative 2x. And 8 plus 1 gives me 9. So we can see we've taken two quadratics, added them together, and we've gotten another quadratic. We should kind of expect that, I suppose. Let's take a look at the next one. Thinking back to adding, subtracting, and multiplying and dividing functions, right? We can see our notation here, right? That means take f of x and subtract off g of x, right? So we've got 2x cubed plus 4x squared minus x plus 6, and we're going to subtract off 5x squared minus 3x plus 1, right? So remember, when you're dealing with this negative, you've got to distribute that negative, right, to everything. So if I go ahead and do that, boom, there we go, right? So now we've got 2x cubed minus nothing, okay? So that's 2x cubed, right? 4x squared minus 5x squared is negative x squared. Negative x plus 3x gives me plus 2x, and 6 minus 1 gives me plus 5. So just like dealing with regular numeric expressions, when we're subtracting, we can think about adding a negative. Same thing, okay? I took a cubic, subtracted a quadratic, and it stayed a cubic, right? But I'm adding and subtracting polynomials and getting polynomials, okay? So polynomial multiplication. We know that multiplying binomials is a lot more complicated than adding binomials, so it shouldn't be any crazy idea that multiplying larger polynomial expressions is more complicated than smaller ones. But we're going to use a similar process. You can use multi-distribution, right? You can take the first term and multiply it by everything in the second and do the same thing, right? And you end up with, super distribution, or however you want to think about it, right? It gets messy, it gets complicated, it's hard to keep track of your terms. It's good to be able to do it, but I want to use the area model, right? So this time, since I have 3 terms in my first one, I need 3 rows across, or 3 columns and 2 rows, okay? So I can put my 3x plus 7 on the right, where I've got my 2 terms, and negative 2x squared plus x minus 1 for my quadratic. And we're going to do the same thing that we did before. We'll multiply in each box. 3x times negative 2x squared gives me negative 6x cubed. X times 3x is positive 3x squared. Negative 1 times 3x is negative 3x. Negative 2x squared times 7 minus 14x squared. So we're going to proceed in this fashion, multiplying and writing our results in each corresponding box. And the last one, negative 7. And just like before, we're going to go ahead and add along the diagonals here. Okay, so the first one is negative 6x cubed. Now we've got 3x squared minus 14x squared. That gives us negative 11x squared. Negative 3x plus 7x is positive 4x. And, well, negative 7 is just negative 7. So our final answer when we're done multiplying is negative 6x cubed minus 11x squared plus 4x minus 7. Another way you can check that is to plug both of these expressions into a calculator like Desmos and graph them and see if they come out to be the same and verify. You can also check by graphing them or making a table in something like a TI calculator. All right, and the last one, you should go ahead and try this one on your own. Pause the video. So this one's a little bit larger. We have 4 terms and 3 terms, so we need a 4 by 3 box. So and it doesn't matter. You can put your 4 on the side if you wanted. I just happen to do it this way. So I'm going to write my terms, 2x cubed plus 4x squared. Again, keeping the signs, okay, always including those signs. And positive 1. Okay, So now we're going to go through and do our multiplication. The big thing here is, again, it's getting larger, but could you imagine multiplying 2x cubed by all three of these things, okay? And collecting that and then doing the same thing with 4x squared. You know, we're going to do that, but it's a lot of information to keep track of. And again, you know, why do all that if we can have a method that's going to do it at the same time? So we'll multiply 2x cubed by 5x squared. We've got 10. Remember, the x cubed times x squared gives us x to the fifth. So now we have a fifth degree polynomial. Again, we have a polynomial. 5 times 4 is 20. And then x squared times x squared is x to the fourth. Okay, we proceed. We get negative 5x cubed, positive 30x squared. Okay, now to the next row. Negative 6x to the fourth, negative 12x cubed, positive 3x squared, negative 18x. In the last row, everything is multiplied by 1. That's easy. We can just write it in. Again, make sure you include your signs, minus x and plus 6. Okay, and the last step is to go ahead and diagonally collect our terms. 10x to the fifth. Okay, 20 minus 6, that gives me 14, x to the fourth. Negative 5 and negative 12 is negative 17, plus 2, that's positive 15, x cubed. 30 plus 3 is 33, plus 4 is 37, so we have positive 37x squared. Negative 18 minus 1 is negative 19, negative 19x. And plus 6. So again, we can see that our product, f times g of x, is going to be this fifth degree, quintic, however you want to pronounce it, fifth degree, 10x to the fifth plus 14x to the fourth plus 15x cubed plus 37x squared minus 19x plus 6. Okay. Again, practice this method because when it comes to polynomial division, we're going to focus on how to use this model to do division as well. Okay? So hopefully that gets you going on the practice assignment for that. Okay, work on that, and if you have any questions, send me emails or come to Zoom office hours. Good luck.